This is example 1.6, and we're learning about scientific notation. So the first problem asks us to convert I'm about to give you the answer. This problem asks us to convert 610,000 into scientific notation, and they want 4 significant figures. So first we know that our decimal point is going to have to go between the 6 and the 1, because one of our first rules is that scientific notation has only 1 digit in front of the decimal place. And to get from where the decimal currently is to where the decimal needs to go means that we have a really big number that we're starting with. So our number that's going to be on the times 10 is going to be a positive number, because if we multiplied it back out, 6 point something times 10 to the whatever, we'd want to make sure we multiplied it by a big number. So in this case, we have 6.1, and we need 4 significant figures, so we need 2 more, so we're going to keep 2 of those zeros. So now we have 2, 3, 4 significant digits times 10. We know it's a positive number. How many places did we move? 1, 2, 3, 4, 5. We moved 5 places to the left, so 10 to the 5. And if you're never not sure about if you got it right or not, one thing you can do is you can take the 10 to the 5 and think, what is 10 to the 5? So by the way, this is our answer. But as we think about it, 10 to the 5 would be 10 with 5 zeros. So if we multiplied 6.100 by 100,000, would it turn into the original number? Yes, it would. If we had gotten something in the other direction, like if we'd put -5, 10 to the -5 would be like a fraction, and so, or a very small decimal. And if we multiplied that by 6, we would end up with an even smaller number. All right, so let's move on to the next one. We want to convert lots of zeros, 4, 5, 6 into scientific notation. Again, we know the decimal point is going to have to be between the 4 and the 5, because we need to have 1 digit in front of the decimal. So 4.56. Now, what do we put for the times 10? If we have a number 4, and we really want it to be 4 way down the decimals like this. This is tenths, hundredths, thousandths, 10,000ths, 100,000ths, right? This is like 4 millionths. We know that we're really not going to be multiplying by some big number. It's like we're dividing, or in other words, we're multiplying by some decimal of 10. So that means that our number here is going to be negative, because to get this 4.56 back to what it really looks like in normal decimal notation, we would need to make it a lot smaller. And then we just count to find where we're going. 1, 2, 3, 4, 5, 6 to get to where we want the decimal. So it's 10 to the -6. All right, so now we're taking a number that has a scientific notation form, and we're putting it into decimal notation. So we're going the other way. So for this one, let's start by just writing our numbers. 8, 1, 2. We can write the 0. We won't need it, but we can write it right now. Now our decimal is here, and because this number is negative, we know that what we're really doing is we're really dividing by lots of tens. In other words, this number is going to get a lot smaller. Which way will the decimal move to get a lot smaller? Will it move this way, or will it move this way? If you said to the left, you're right. Oh goodness, I'm drawing a triangle. So our decimal is going to have to move this way 12 times. So imagine it here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we just fill in all of those empty spaces with zeros. And because this 0 in the end turns out it's after a decimal point at the end of a number, we actually do need to leave it, because it is significant because of where it falls. Let me see if I can get rid of my bumps. Oh, I did, but I lost my decimal. I'll put it back. So that is the number converted to decimal notation. You can see why scientific notation would be useful here, because that's a really obnoxious number to try and read. All right, and then we have one last one. This time our 10 to the whatever is a positive number. In other words, we're going to take this 3.4 and we're going to make it bigger. We're multiplying by 10 with lots of zeros on it. In other words, my decimal place is going to go that way because we want this number to be bigger. Because in reality it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the decimal would go there. And we can fill in our zeros, which Microsoft Whiteboard is going to turn into pretty ovals for me. And I believe I can probably get rid of this bumpy thing here. That way I can, it always gets rid of my decimal point. And that means I can add in, I really don't need that decimal point or the 0 at the end. I can just remove that. But I am going to put in some commas. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, and that is our final answer. Again, you can see why scientific notation is useful. If you were working a problem with this number, you would possibly lose track of all the zeros in trying to manage it. All right, if you have any questions about scientific notation, you can call me, text me, talk to me in person, ask me in class. And if you feel pretty confident, go ahead and try the comprehension check problems 7 and 8 and see how it goes.